This is part one of three parts of understanding how prices emerge to coordinate human behavior. And in this first video, we're going to look at demand and the demand curve. To explain demand, we can do this one of three ways. First, we can do it mathematically. The quantity demanded of some item is equal to some function of the price of that item. In this case here, we're going to use quantity demanded is equal to 10 minus P. So our function will be 10 minus the price of whatever good we're talking about. We can also do this verbally, and in doing so I wanted to take this chart to the right and I want to use my mathematical formula to give every price quantity combination. So for example, when P is 0, quantity is 10. When P is 4, quantity is 6. When P is 10, quantity is 0. So I can do it mathematically, I can do it verbally, and lastly we can do it graphically. And in this case here, we'll start with quantity on our x-axis going from 0 units to 10 units. We'll put price on our y-axis going from $0 to $10, and now we can plot out these points using our math equation or from our graphical chart to the right. And so in this case here, at a price of 0, consumers are willing to purchase 10 units of the item. At a price of 10, consumers are willing to purchase 0 units of the item. At a price of 3, consumers are willing to purchase 7 units of the item. At a price of 8, consumers are willing to buy 2 units of the item, and at a price of 5, consumers are willing to buy 5 units of this item. So here we've plotted out 5 of the 11 data points available to us in this chart, and we can draw a line through these data points, and this gives us our demand curve. If we had plotted out these other data points, they would have fallen along this line as well. And what the demand curve represents is how much consumers are willing to buy at different prices, as represented in the equation and in our schedule to the right. Why does the demand curve slope downward in price quantity space? Well, to answer this, let's ask a couple of questions. First off, why does a bottle of water sell for $1 while a diamond sells for thousands of dollars? A bottle of water sustains my life, a diamond does no such thing, yet we're willing to pay so much more for a diamond and so little for a bottle of water. Similarly, why does the average teacher in the United States earn about $55,000 a year while the average NBA player earns more than $5 million a year? A lot of people confuse this and think we must care a lot more about athletics or professional sports than we do about education, but that's not true at all. We spend far more money on education. It's just the average teacher makes a lot less than the average NBA player. Well, let's think about this for a second. We have so many millions and even billions of bottles of water or available clean water to us. Adding one more unit does not necessarily improve my happiness that much. There's plenty there. Adding one more diamond improves my happiness a lot because diamonds are very rare. There are few of them. So therefore, if another one comes about, there are far more people willing to pay a lot for it because there are so few available to go around. Same thing with an NBA player. Adding one more person with the qualities of an NBA player, someone able to do the work they do, those are very rare skills and rare talents, and therefore they're able to command a lot of money in order to work for you. Whereas the average teacher, there are far more people with the ability to teach than what the average NBA player is able to perform on the basketball court. So what we call this is diminishing marginal utility. The more of something we have, the less utility an additional unit provides us, and the less we're willing to pay for that additional unit. So I'm willing to pay a lot for a diamond because there are so few. Moved on along the demand curve to the right, and that's where bottles of water are. We have far more of them, therefore I'm not willing to pay a lot more for an additional bottle of water. I'm willing to pay a whole lot of money for the only bottle of water available in the world, but I'm not willing to pay a lot of money for one additional given all the water we have. Same thing with the NBA player. What this also tells us, and is part of diminishing marginal utility, is what we call diminishing marginal rate of substitution. In order for me to purchase something, I have to give up purchasing something else. In this case here, when the price of something rises, that good becomes less attractive relative to other goods I can buy, and I substitute away. So if the price of soda rises, orange juice and milk or orange juice and water become more attractive substitutes, and I will buy more orange juice and water. On the other side, when the price of soda falls, then that becomes more attractive than purchasing orange juice or water, and I substitute away from orange juice or water and buy soda. When we look at a market demand curve, we are simply horizontally summing individual demand curves. So at $1, if two people are willing to pay, or let's say at $1, you have two people willing to pay to buy 4 units and one person willing to buy 2 units, then we have a total demand of 10 units at $1 based on 3 different people. So a market demand curve simply horizontally sums all the individual demand curves, and therefore we're going to see some people who have a much higher demand for an item than somebody else. Somebody may be willing to pay $8 for a gallon of gasoline. They have a very high marginal value on a gallon of gasoline or the next gallon of gasoline. Somebody else is willing to pay far less. They may only value it at $3. They have many substitutes for gasoline or cars or driving. They don't need it as much. Therefore, their marginal value is less. So along a market demand curve, again, it's a horizontally summing individual demand curves, and individuals have different values they place on specific items. Looking at our demand curve here, within the green region underneath the demand curve, every price quantity combination within that region consumers are willing to purchase. Outside of that region, they are unwilling to purchase. Any price quantity combination outside that, above that demand curve, consumers are not willing to purchase. So for example, at a price of $6, consumers are definitely willing to buy that first unit. When we look to the right, that first unit they value at $9, and yet they only happen to pay $6 for it, so they are definitely willing to buy that first unit for $6. They are unwilling, however, to buy the 8th unit for $6. It's not to say they wouldn't be willing to buy 8 units for $6. They certainly would. They're not willing to purchase the 8th unit for $6. That's outside of that demand curve region. Therefore, that is an area that's a price quantity combination that consumers are not willing to purchase. If consumers could purchase all 10 units, and the price of course would be $0 to do that, then the total value to consumers is $50. That's the area within that triangle. Consumers value consuming these items, these 10 items, at a total of $50, and therefore we'd say that's the total consumer value would be $50. If we had a quantity of 5 units only, there are only 5 units available to us, to the left of this fuchsia dotted line are consumers who have a high value for these 5 units. These are the ones that we want to have these, the few units that are available. We want those lying on the left who have a much higher value for these units to have them. Those to the right have a lower value for these 5 units. We don't want them to obtain these because that means somebody else with a much higher value for it doesn't get it. Think of a bag, there are only 5 bags of ice available, and there are people who have a very, very high value for a bag of ice. There are a couple people with a very low value for a bag of ice. We want those for a high value of a bag of ice to obtain that. Well, that's what price does for us. When the price is $5, only those consumers who value ice, so the next bag of ice for $5 per bag, will obtain one. Those who aren't willing to pay $5 have a lesser value for it, therefore they will not get some of the scarce ice. Now let's start with a price of $5, and we look at our demand curve and we see that at $5 consumers are willing to buy 5 units. The total value to consumers at this 5 units is $37.50. Again, when we said 10 units would be consumed, that would be $50, but given we're only going to consume 5 units because the price is $5, total consumer value, the value consumers get from consuming these 5 units, is $37.50. Of that $37.50, they had to pay $25 to the seller to obtain these 5 units. 5 units times $5, that's $25. Subtract that out from the $37.50, and what we end up with is consumer surplus totaling $12.50. Consumer surplus is the value consumers receive above and beyond what they paid for this item or these items. Consumers valued 5 items at $37.50. They had to pay $25 to obtain those 5 items. Therefore, total consumer surplus is $12.50. At a price of $8, consumers are willing to buy just 2 units of these items. The total consumer value here is $18. But in order to obtain these 2 items, they had to pay $16. Therefore, total consumer surplus is just $2. A little different than we just looked at before. And similarly, if we look at a price of $3, consumers are willing to purchase 7 units of the item. Total consumer value in this case is going to be $45.50, but of this $45.50, they had to pay $21 to obtain these 7 items. Therefore, total consumer surplus would be $24.50. And again, consumer surplus is the value consumers receive above and beyond what they paid for these items. Now I want to take a break for just a second to understand something about a demand curve. And in order to do that, let me do this experiment. Let's say I want to run an experiment. I want to determine the effect time spent studying has on a student's GPA. So in this case, what I want to do is I want to poll students, and I want to ask them how many hours a week they spend studying, and they tell me truthfully, and then I map that out against their overall GPA. And every one of these dots represents an individual student. So for example, this student down here studies just a little fewer than 6 hours a week, and it looks like they have about a 0.75 GPA. This student up here studies fewer hours, it looks like just over 4 hours a week, and they have a 4.0. And when you look at this student over here spends about 20 hours a week, maybe a little more, and they too have a 4.0. So given this dispersion of data, it looks like there really is no correlation between time spent studying and hours per week, time spent studying and GPA. In fact, when I add this trend line, it's perfectly horizontal. An additional hour spent studying does nothing for a student's overall GPA. Well, that really defies logic. That doesn't make sense that if a student spent an additional hour or two studying each week, that their grade would increase. What might be wrong with this? Well, we have to look at other factors that would contribute to a student's GPA. For example, IQ may be a good predictor of GPA. Students who are naturally intelligent are probably going to be able to obtain a higher grade for a given number of hours spent studying each week. Therefore, we want to control for IQ. And what that means is I want to take students whose IQ is between 80 and 90 and compare their time spent studying and their GPA. And those students whose IQ is 90 to 100 and compare their time spent studying with GPA, and 100 to 110, and 110 to 120, and so on. And what I'm doing is I'm making a relevant comparison of time spent studying and GPA based on individual IQs that are correlated together, that are common together. Number two, I might look at the difficulty of classes. Maybe the student in the lower left who studied just fewer than 6 hours and has a 0.75, they took very difficult courses like physics and economics, where the student with the 4.0 who studied just over 4 hours per week took a lot of easy classes such as pottery and playing guitar. Those were much easier courses. So we want to factor out the difficulty of courses. And what we might do is simply use, if we're running a regression, we might use a variable, quantitative variable for the difficulty of classes. The more difficult the class, going from 0 to 5, the easiest class might be a 0. We want to also look at SAT score maybe. Maybe SAT score has an effect on a student's overall GPA based on the time spent studying. SAT is not a test of intelligence like IQ is. SAT is a test of your readiness for high school or for college, actually your readiness for the first year of college. Students with a low SAT score may not be very well prepared for college level work relative to somebody with a higher SAT. Therefore, once they both get to college, the person with a higher SAT grasps things more quickly and moves on relative to the student who really didn't have a good background to begin with, and they're simply playing catch up. And lastly, you might want to control for a roommate. Maybe if your roommate's a partier, that adversely affects your GPA, and if your roommate is studious, that positively affects your GPA. So we might want to control for these different variables. And if we do, we might end up with a distribution that looks more like this. Once we control for those other 4 variables, now we get a relevant comparison of time spent studying and a student's overall GPA. And we can put in our trend line, and what this model is telling me, what I'm trying to get from my model here, is I want to know how time affects a student's GPA holding the other factors constant. And what this allows me to do is to measure the change. So if a student goes from spending 10 hours a week studying to spending 12 hours a week studying, I can make a relevant comparison. That's movement along my line here. That's what my model is trying to determine. How much time spent studying, what effect that has on a student's GPA. That would be movement along that trend line that I have situated. Now, what happens if one of those other variables, IQ, difficulty, SAT, or roommate, changes? What I just looked at now was time changed. When the time changes, since that's what I'm really trying to determine in my model, that's movement along that line, holding these other variables constant. But if one of those other variables changes, let's say the Flynn effect. The Flynn effect says as our society moves on, as we develop more, we have a more complex society. In order to deal with that complexity, average IQs rise. Well, if average IQs rise, that's got to change and shift this curve up. Now, all these other individual dots would also have shifted up. I haven't moved them, but the line shifts up to show that in any given number of hours spent studying, IQ today would be higher than, say, IQ 40 years ago, because we have high. I mean, a GPA would be higher today relative to GPA 40 years ago, because we have higher IQs today than we had 40 years ago. So any change in IQ, difficulty of the classes, or SAT or roommate, that would shift the curve up or down. And this would also help us, like I said, when we sort out and separate the different variables, say students with an 80 to 90 IQ, 90 to 100, we would have 4 different trend lines that we would be comparing. Well, the same is true of a demand curve. When we look at how much people are willing to buy, price is one factor. That's what we're trying to determine in our model. How much consumers are willing to buy at different prices, and that's movement along that demand curve. But we also have other things that cause us to buy. Number of consumers. The more people willing to buy something, the more they're going to be sold. More people are willing to live in Manhattan than in a small rural farming community in Iowa. Therefore, rents in Manhattan are going to be much higher than rents in a small community in Iowa. Income. Families with bigger incomes tend to buy more than families with lower income. What we look at is when our incomes go up, we buy more normal goods, we buy fewer inferior goods. So for example, clothing, housing, and cars would be normal goods. Ramen noodles would be an inferior good. As your income goes up after you leave college, you're not likely to eat ramen noodles that much longer. The prices of other goods, complements and substitutes. If we're looking at the market for tea, when the price of coffee rises, that causes the demand for tea to increase. Coffee rising causes the price of coffee increasing causes people to substitute away from coffee and buy more tea. Therefore, the demand for tea increases. If we're looking at, say, the market for jelly, and the price of peanut butter rises, well, if I only will eat peanut butter with jelly, the price of peanut butter rises, mean I want to consume less peanut butter. Well, that turns into a decreased demand for jelly then. So if we're looking at the market for jelly and the price of peanut butter rises, the demand for jelly falls. That would be a complement. When we look at complements and substitutes, the price and quantity changes move in the same direction. When we look at complements, they move opposite each other. Taste. If we're looking at the market for, say, milk, and a new report comes out saying drinking 4 glasses of milk every day is not good for your health, then we would see the demand for milk fall because people would be substituting away from milk. And lastly, we want to look at expectations of future price increases. If I expect the price of gasoline to rise by $1 next week, I'm going to go out today to fill up when the price is cheaper. That's going to cause the demand for gasoline to rise. Conversely, if I expect the price of gasoline to fall next week, I'm going to refrain from filling up my car today. So will other people. The demand for gasoline falls today. So we can look at this and try to gauge what's going to happen. What happens to the demand for cream when the price of coffee increases? Well, again, in our model here, this is the market for cream. The quantity demanded of cream is equal to some function of the price of cream, holding these other factors constant. Well, in this case here, the price of a complementary good increased. Therefore, we ought to expect the demand for cream to fall as the price of coffee rises. So the price of coffee rises, I'm going to consume less coffee. I don't need as much cream now because I'm not drinking as much coffee, and therefore the demand for cream falls. And what we can do is we can look at this and see that at any given price, consumers are willing to consume less cream. We went from $5, we were willing to consume 5 units of cream. Now we're only willing to consume 4. And at $4, we were willing to consume just 4 units of cream. Now we're willing to consume at $4, consumers were willing to consume 6 units of cream. Now they're only willing to consume 5 units of cream. When we look at the market for peanut butter, what happens when the American Medical Association publishes a report saying eating peanut butter is great for your heart and it really helps? Well, again, the quantity demanded of peanut butter is equal to some function of the price of peanut butter, holding these other factors constant: consumers, income, price of other goods, taste, and expectations. Well, this is going to be a change in taste because now people have a greater need or desire for peanut butter. That's going to cause an increase in the demand for peanut butter. And again, what we can see is at any given price, consumers are now willing to go from, say, $5 consuming 5 units, they now want 6 units of peanut butter. And conversely, at 5 units, at $5, with 5 units, they were willing to pay $5. Now they're willing to pay $6 for that 5th unit of peanut butter. Lastly, what happens in the market for cell phones is the price of cell phones decreases. The price of cell phones decreases. Well, again, when we look at our market here, the price of cell phones decreasing is movement along that demand curve. It is not movement of the demand curve. Remember, in our model, we're trying to determine the effect price has on quantity demanded. That would be movement along that demand curve. And in this case here, quantity demanded is some function of the price of cell phones. That's what changed. The other factors didn't change at all. Therefore, this would be movement along the demand curve. And what we say is there was an increase in quantity demanded.